next one. Now, where is the next one? There it is. Here we have been taking our rational functions and breaking them down. Yeah, I got 9 minutes. I can do this. We need to build a rational function now. We want to build a rational function that meets the following criteria. Let me get this printed out for me. Oh, that's still yours. Thank you. It has vertical asymptotes at x equals negative 9 over 8 and x equals 8 over 9. And it has a horizontal asymptote at y equals negative 2 over 72. And it has x-intercepts at negative 9, 0, and 8 halves, 0. I know that's 1/4, but bear with me on the 8 halves. I mean, I know that's 4, but bear with me. There's a reason for this. You will find that your homework problem or two like this does not simplify things. So for instance, the 8 halves. Keeping it unsimplified makes your life easier later in finishing this problem. Vertical asymptotes. Where do I find my vertical asymptotes? By using my denominator. So if I work backwards from my vertical asymptotes, I should be able to end up with the polynomial that's in my denominator. Yes? Yes. So let's work backwards. So if I have... That just scares me to no end. So this is for my denominator. I have x equals negative 9 over 8 and x equals 8 over 9. Now the tempting thing is to just move them over, but let me warn you, it's nicer not to. Instead, the nicer thing is to take the denominator and multiply both sides by the denominator. When I do that with this one, what will I get? 8x equals negative 9. And then I can move the negative 9 over, so I'll get 8x plus 9 equals 0. And you'll see why it turns out nicer when you do this. It'll make this horizontal asymptote come out much better. What about this one? What should I do to get it? Multiply by 9. So I'll get 9x equals 8, and then 9x minus 8 equals 0. Now when I put them together, my denominator polynomial would be 8x plus 9 times 9x minus 8. That will be my denominator. Now there could be a leading coefficient here, we'll call it A just for fun, that might have gotten lost in this process. Now, how do you think I'm going to find the numerator? You look back at the work that you've done on in that last problem where you were working on x-intercepts. Or the first problem when we did x-intercepts too. What did we do? We set the whole thing equal to 0 and then we cross-multiplied, yes? What did that cross-multiplied step look an awful lot like? Once we were done cross-multiplying, what did we have? 0 equals what? The numerator. So we can use our x-intercepts and the fact that in the process of finding them, we found the numerator equal to 0 to build the numerator polynomial from the x-intercept information. So we're going to do numerator here. Now in the process, we ended up with, here are our points. What was the step before we got the points? What did it look like before I made you make many points? X equals. So I had x equals negative 9 and x equals 8 halves. Yes, I know, that's cool. Now if I go through the same process I went through here with this one, I'll end up with my numerator polynomial. That's easy. Just move the 9 over, so x plus 9 equals 0. This one, here's why it's nicer this way. Multiply by the 2, So I have 2x equals 8, and then 2x minus 8 equals 0. So my numerator polynomial looks like some number, we're going to call it b this time because we used a over here, times x plus 9 times 2x minus 8. So my polynomial vaguely looks like the following. My rational function looks like the following. F of x equals b times x plus 9 times 2x minus 8 divided by some number times 8x plus 9 times 9x minus 8. Am I done? Well, not if I still have an a and a b in there. What part of the information that I was given about this rational function have I not used? My horizontal asymptote. So, as x approaches infinity, what is important in this thing? Well, the leading coefficient, this x and that 2x, yes? So that would be f of x is going to go to 2 times b times x squared. What's important in my denominator? A, 8x and 9x, right? So I would have 72 times a times x squared. Yes? We're okay so far? What happens to the x squareds? They go away. So this is going to approach 2a, b's on top, 2b times 72 over 72a. Well, what is that supposed to be? Well, it's supposed to be negative 2 over 72. Yes? And I've got 2 over 72, so what do I need to make a or b? Pick one, it doesn't matter which one you pick. Negative 1. And the other one would then need to be 1. So if I make b equal negative 1 and a equal 1, that will come out fine, right? Yes? And it'll match my polynomial, my rational function information. And basically I just built the polynomial that's the numerator and the polynomial that's the denominator. Now, there is one problem in your homework where you are asked to